Today we are going to start with a new chapter, and the name of the chapter is Electric Current and its Effect. Now, before starting this chapter, we need to understand the symbols of electric component. Now we are having 6 electric components, their symbols and their diagrams. Now for example, electric cell. The electric cell, we know that the diagram is given over there, and how do we draw a symbol? We take a large line and we take a small line, and the large line is the positive terminal and the small line is the negative terminal, and the horizontal line are the wires. The next is electric bulb. The electric bulb is given by a symbol like this, and we encircle the electric bulb symbol because that denotes the bulb. The next is switch in off position. We take 2 horizontal wires, and when switch is in off position, the switch is not connected. Therefore the switch is, we can see that the switch is open. And the next is switch is on position. When switch is in on position, the current is flowing through the circuit. Therefore, the switch is connected and we can see the switch touches the wire. The next is battery. Now battery, what is a battery? Battery is a combination of 1 or 2 more cells. Therefore, when we combine more than 2 cells, we take a battery. For example, in this we are having a battery of 3 cells. Now next is wire. A horizontal line is denoted by a wire. In this chapter we are going to study about what is electric current, what are the symbols of electric current which we have just started, and the next are heating effect of the electric current. What happens when electric current flows through a wire? Now the next is electric cell. We'll start with the very smallest component, that is electric cell. The electric cell, you can see the electric cell in your torches also. When you open the torch, you see a simple cell that is known as electric cell. Now the electric cell is having 2 terminals. One is positive and another is negative. The positive terminal is on the upper end of the electric cell and the negative terminal is on the lower end of the electric cell. Now what happens when we combine 2 electric cells or more than 2 electric cells? When we combine more than 2 electric cells, we actually make a battery. So this is a battery. Battery is a combination of 2 or more electric cells. Now how do we represent? As I have already told you that we represent through a large line and a small line. Now battery. Again I told you the battery is a combination of 2 or more cells. Moving on, how we draw a simple electric circuit. Now here we take electric components and we attach those electric components with wires and we obtain a simple electric circuit. A simple electric circuit can be made using a cell, electric bulb, switch and wires. The bulb glows only when the switch is in on position and the circuit is closed. So this is how we see a simple electric circuit. Now we have 2 circuits. One is a closed electric circuit and the another is open electric circuit. Now the only difference between these 2 circuits is, in this the switch is in off position, the first thing, and the second is switch is in on position. That is why it is open, because no current is flowing through the circuit, and it is closed because the current is flowing through the circuit. Moving on, we have heating. Then now there are 2 effects of electric current. We know that one is heating effect and another is magnetic effect. Now we will study what is heating effect of electric current. When electric current flows through a wire, the wire gets heated. This is called heating effect of electric current. We have seen this heating effect how we actually make an electric circuit. Now we take a nichrome wire, we attach the nichrome wire with a cell, and we attach a switch also. Now when the switch is in on position, the current is flowing through the electric circuit, and when the current is flowing through the electric circuit, the nichrome wires get heated. Now what does it denote when the nichrome wire gets heated? Because nichrome wire is heated because of the electric current flowing through the nichrome wire. This shows that there is heat produced in the wire when electric current is flowing through the circuit. Now when we touch the nichrome wire, we see that the nichrome wire is hot. This tells us that whenever electric current is flowing through the circuit, heat is produced. Now when you can see this in your daily life also, when you touch your TV, after certain time your TV is hot. This means that heat is produced when current is flowing through the circuit. Also the fan is also hot. The fan when switched off is hot. Any circuit, any appliance we are using after certain times becomes hot. Moving on, we can use this to our benefit. So we have uses of heating effect of electric current. Now what are the uses? The heating effect of electric current is used in electrical appliances like electric heater, electric room heater, electric iron and electric current. And the amount of heat produced in the wire depends upon its material, length and thickness. Now when we, for example, we use electric iron in our daily life. Now the electric iron, whenever we switch on the electric iron, it becomes hot. And when we start ironing our clothes, what happens? The electric iron is hot. Why it is hot? Because the electric iron is having a kind of element which becomes hot. The kind of element becomes hot and it gives off radiation and it makes the electric iron hot because of the flow of electric current. Moving on, electric fuse. Now what is electric fuse? Electric fuse is a safety device. Now suppose there is a castle, okay, and there is a bridge. Now the bridge can support only 5 soldiers. Now suppose when there are 6 soldiers, the moment the 6 soldiers enter the bridge, to step on the bridge breaks and it saves the castle. This is how electric fuse is used. Now electric fuse has certain amount of rating of the current and it is having a thin wire. So whenever electric current less than that rating or of that rating passes through the electric fuse, it saves the appliances. But if there is large amount of electric current which passes through the electric fuse, now when the large amount of current passes through the electric fuse, this electric fuse breaks because it is having a thin wire and the thin wire gets heated because of the application of electric current and it breaks, thereby saving the appliances. Therefore it is known as a safety device. Now electric fuse which we uses a copper wire. So for example, if the electric fuse has rating of 5 ampere and 6 ampere of current passes through the electric fuse breaks down, and what happens when it breaks down? It saves the appliances. Moving on, the next effect is magnetic effect of electric current. In this we are going to study only 2 topics, that is electromagnet and electric bell. When electric current flows through a wire, it behaves like a magnet. This is called magnetic effect of electric current. For this, what we have seen, we take a cardboard tray from a matchbox, wind an electric wire with a few times around a cardboard tray. We place a small compass needle inside it. We connect it to the cell. The moment current starts flowing through this circuit, we see that the compass shows the deflection. And we see when the compass starts to show the deflection, this means that if it is showing deflection, therefore there is magnetic field surrounding a particular area. That is why the needle of the compass starts deflecting. So this shows us whenever electric current is passing through a wire or whenever electric current passes through a wire, it produces magnetic field or magnetic effect. Therefore the magnetic needle of the compass starts to show deflection. Now we can use this magnetic effect of electric current to our benefit by making an electromagnet. Now what is an electromagnet? The electromagnet is when electric current is passed through a coil of insulated wire wound around a piece of iron, it becomes a magnet. Such a magnet is called electromagnet. We have done an activity. What is that activity? We take an iron nail and we wind a copper wire around an iron nail. We connect it with a cell. The moment we switch on the cell and electric current passes through the wire, this particular iron starts attracting iron clips towards it. But whenever we switch off the cell, this electric iron, this does not connect the electric clips anymore. This shows us that on the application of electric current, this iron nail behaves as electromagnet. So this is a simple electromagnet which is made up of iron nail. And when we switch off the electric current, this iron nail is no more an electromagnet but a simple electric iron. Now next is this electromagnet we can use in electric bell also. Now what is an electric bell? We have seen that this electric bell in our schools and in offices, this electric bell composed of an electromagnet. Now the electric bell has a coil of wire wound around a piece of iron which acts like an electromagnet. An iron strip with a hammer is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, current flows through the coil and becomes the electromagnet. It pulls the iron strip and the hammer at the end of the strip strikes the gong of the bell and produces sound. When the electromagnets pull the iron strip, it also breaks the circuit. So this is important. When the electromagnet pulls the iron strip, it is breaking the circuit and it is hammering against the gong. Now whenever it goes back to its position, again it is connected to the circuit. Therefore again the current starts flowing and that particular magnet and the particular iron behaves as electromagnet, and again it pulls the iron strip. Now this process repeats till the moment electric current is the switch is on and it strikes the gong. Therefore we see that we can hear the sound. And this iron strip comes back to original position and the process repeats and the bell rings. So in this chapter we have studied about light and about the two effects of the light, that is heating effect of light and magnetic effect of light, and the application of heating effect of light, heating effect of electric current, and the application of magnetic effect of electric current. Thank you.